Oh, hello world.
We're like a big pat.
Yeah, that's great. That's a good intro.
Holy crap, okay.
I can riff it from there. There we are. Welcome to Melbourne CocoaHeads 180. Woo! In the spirit of reconciliation, Melbourne CocoaHeads acknowledges the traditional custodians of country throughout Australia and their connections to land, sea and community. We pay our respects to their elders, past and present, and extend that respect to all Aboriginal and Torres Strait Islander peoples today. Tonight we have a good lineup. We have some great talks. Laura Shuffleberger. I messed up the first name. Okay, rehumanizing the technical user. Looking forward to it. Amy Delves, down the road, and Rob Amos, or Bok, aka Bok, bringing distributed tracing to your iOS apps with open telemetry. Great work. Give them a round of applause early. A preemptive applause. We have a code of conduct here at Melbourne CocoaHeads. If you see anyone sort of uncomfortable or being harassed or notice someone sort of in a difficult situation, bring it to our attention, the organisers. They may have a pin, like a little CocoaHeads pin. There's also an anonymous form online, the code of conduct form that you can fill in. I can read out the last, it's just code of conduct, yeah, okay. Fantastic, you can fill in that form if you feel more comfortable doing that, great. Just be nice to people. What is that from? Be excellent to each other. Is that the thing? Great. Housekeeping. The toilets are outside, past the list to your right, and they're just near the emergency exit. So we haven't had to use it at this point, the emergency exit that is, and yeah, hopefully not tonight. Great. Name tags. If anyone's got a blue tag on, it means they're new, but I'm not sure if we made that clear at the door, but yeah. Look, it's all right. You're wearing a blue shirt. It's just as good. Okay. It's also an online streamed event, so if you've got any questions, we normally do that at the end of the thing, unless the speaker specifically engages and says, do you have some questions? So yeah, you can ask in the Slack channel, which we'll talk about shortly. Yeah, great. Thank you to our sponsors. Mantle Group is our gold sponsor. They're hosting the event tonight. We're at their office. Thank you, Mantle Group. Great. And also REA Group. Thank you very much, our silver sponsor. Some other things that are happening in the Melbourne CocoaHeads community. The coding night is on Wednesday, the 16th of October. Yeah, it's a night you can bring your laptop, work on your projects, get some help from people. It's an alcohol-free event, so sometimes people bring their kids to learn. It's great fun. Oh, it's a joint event with Google as well, Google and Flutter. So they all come here and we set up laptops and stuff. Come along. There is the social night, Tuesday, the 29th of October at La Rouge, Saint and Rogue. Saint and Rogue on Little Collins Street. Some other groups that are, what do we say that we're friends with? Sydney CocoaHeads, GDG Melbourne.
Sorry, that was me.
What happened? Okay.
Nothing.
Yeah, all good. And there's a little QR code down there that you can just get, and that has a list of all the CocoaHeads community in Australia and New Zealand. Slack. No, how to find us, melbournecocoaheads.com, that's our website. There is also a Slack, which you can scan the barcode. Don't know what the address is, but I'll keep that up there for a bit. And Mastodon, which I hear is great. Question? No, I'm joking. Slack, here we are, some channels. It's a joint Slack with Australia and New Zealand. The Melbourne ones are prefixed with Melbourne -hyphen. Melbourne meetup is about tonight, but there's also Melbourne volunteers. This night is organised by volunteers, so if you want to jump on board, please jump in there and just get involved. If you're looking for a job or need someone for a job, go to #jobs. And then if you want to speak, which is we're always looking for speakers, it can be a 5-minute lightning talk or what's the limit? 45 minutes? What is the limit? I don't know. Depends. You could break it up over 2 talks if you want to go longer. But yeah, jump in the speakers. Or if you have a suggestion for something you want to see, jump in there as well. Okay, I think we're going to kick things off, right? With Laura, who can make her way up to the stage quickly, and I'll pat her a little bit just to buy us some time. I forgot to give a heads up there, and we'll go into the next thought. Thank you, Laura.
Welcome. Thank you for joining either in person or virtually. My name is Laura, and I'll be talking about rehumanizing the technical user. To kick things off, I'll share a little bit about me. I'm a software developer, a dancer, and an inspiring amateur DJ. I've had a mix of roles throughout my career, including technical account management and solutions engineering. And in more recent years, I've worked on accelerator tools and self-service capabilities where my user is also a software developer. And while working in tech for tech might sound quite distancing from user experience, working in tech for tech has amplified my curiosity and how people from all types of backgrounds make sense of technologies and choose to describe them. For example, in her memoir, Life in Code, Ellen Ullman describes two clients arriving at their workstations, never having used a browser before, spending about an hour clicking around, surfing the web. The users attempt to convey their respective experiences, but unfortunately, and understandably, language fails them. One declares they clicked on a link, while the other counters with the fact they clicked on a picture. One recounts seeing a library, the other is certain they saw City Hall. And neither are able to calibrate. Neither are able to shake their cognitive priors, or in other words, their expectations from previous computer programs. Like any user, a technical user is influenced by their cognitive priors. A user becomes technical by building deep expertise in some number of products or tools relevant to their industry. And at some point in their career, they will experience a need or a mandate to use a different set of tools, in which case they may need to unlearn certain habits. For example, a professional photographer switching to a new camera brand might have to relearn button placement and adjust manual settings to match their preferences. Similarly, a chemist moving to a new lab might start making use of unfamiliar settings on familiar equipment in order to conform to a new set of controls. As a software developer, I've seen firsthand how we're expected to adapt without being briefed on context. For example, a new starter joins a development team and is assigned their first coding task on the basis that they were hired to do Python or do Node.js. But just because a developer knows a language or tool doesn't automatically mean they'll understand how the broader solution context and organizational controls affects its use. And when the names of programming languages or technology products and tools dominate a team's vocabulary, it becomes difficult to distinguish between assumptions and facts. I've participated in many jargon-heavy design time conversations riddled with hidden assumptions while working in tech for tech. It's so easy for technical people to misunderstand each other when the focus is solely on the named technologies at play. These conversations about developing new features tend to go something like this. In discussing a new API subscription feature to be built, one developer stresses Terraform and a bit of config. The other states the fact that some human is able to use YAML and config test. One references YAML again, while the other insists Terraform is sufficient. And the conversation ends with a sense of agreement. It feels like alignment happened, but it didn't. Neither developer uses natural language to describe the feature or considers the developer user touchpoints. These conversations echo the exchange between the internet surfing colleagues from 1995. The shape of the conversations are very similar. The participants are confident in what they recall or visualize, but are not able to calibrate on the feature or experience being described. In the case of technical teams leaning on jargon, language fails them because they are using named technologies as a proxy for user experience. Traditionally, a developer will think of their user as a layperson, as an end user somewhere far, far away. In the developer's mind, a user is an outgroup, and from social psychology, we know there's a fairly low bar for a group of humans to see another group of humans as different and separate to them. On the flip side, when you as a team are developing solutions for users who are also technical, it's easy to treat them as part of your in-group. And this is when naive realism kicks in, because the developer identifies so much with their developer user, their perception of the world is treated as like for like with their user's perception of the world. The developer expects their user, a member of their in-group, to understand what is meant by the Terraform. But technical jargon like the Terraform and conf test does not, on its own, explain what the developer user needs to interact with in order to do something like subscribe to an API. Something that can be done instead is to identify the key personas and map out a journey. And that can be used as a visual anchor for design time discussions. Here's a sketch describing a sequence of technical interactions for subscribing to an API with things like YAML, conf test, and Terraform in the mix. Let's say we have an app developer looking to start consuming a new internal API within their organization. And let's say the API lifecycle management platform or API gateway relies on source control for disaster recovery. Now, before this developer can start consuming an API from their runtime, they need to subscribe to it with the appropriate details like their usage tier or rate limiting. The application owner, which could be, say, a product owner, has a stake in this initial part of the journey and may play a role in reviewing these details. Now let's say the app developer fills out the subscription details in a YAML file and commits that to a source control repository. This triggers a CI/CD pipeline that validates the contents of this file using conf test. And if all goes well, the app developer merges their changes in the repository, and a CI/CD pipeline translates those subscription details into a set of Terraform resources. These resources, which may include things like credentials and rate limiting details, are then applied to the organization's API lifecycle management platform. A team focused on improving the developer experience might notice an opportunity to shift left here. The app developer could validate their subscription details before even committing their changes to the repository. While conf test is a tool that can be easily searched, downloaded, and installed as a CLI, the team will need to consider how to best package and distribute the repository along with the custom validations required to pass for a successful subscription. A journey like this one enables the team to start having discussions on the who and the what and the when, and not just the underlying solution supporting the developer experience. Back in 1995, our internet friends didn't have much language readily available to them for describing what they had experienced. Over time, the language to describe the relevant personas and journeys and touch points evolved and now feels very familiar. But as the internet was developed and made readily available to the general public, IT professionals and the creators of the internet did have some language to lean on from their priors. Interaction paradigms of graphical user interfaces and a military-operated network was not wildly far off from browsing the web by clicking on a series of hyperlinks. And the language we have available today will be precursors to what is ahead. Just like the creators of ARPANET brought their previous language on networks, terminals, and graphical user interfaces to the internet, the language we have today will carry into who knows what in the future. If these ideas resonated with you today, take them back to your team, practice using natural language, and bring to the surface the unspoken hidden assumptions that you as a team are making about the user. That's it for me. If you would like to connect on LinkedIn, QR code is just up there.
Any questions?
Was that a real transcript of a real conversation?
The first one from
The Terraform one?
95 was. The second one is not a real transcript, but I've heard a back and forth like this across various teams and various contexts and just swapped out the details. So personally, I have never even used conf test, although I am kind of interested in it. And I did mix some various things up to make it entirely made up.
How do you know like where the level is in terms of like who you're like what's natural language to developers and like natural language to users and stuff like that? Like where do you draw the line? Because some stuff, like you said, CI/CD, but someone might not know what that is. Like, does it become like too verbose at some point? Like, yeah, how do you identify that line?
It does get a bit wordy to say over and over again source control platform versus just saying GitHub, or saying, like you mentioned, CI/CD platform versus the named technology. But the named technology can be a way to bring to the surface those hidden assumptions. So one person talking about a particular named technology might be intending for the user to interact it with one way, but when another person hears it and doesn't have the full context of what that journey looks like, or the other boundaries that might be in place, or organizational constraints, some other person might have a completely different idea of how that then gets interacted with.
So like the purpose, like you should understand what's actually happening rather than the names of things.
Yep.
Cool. Anything else? Awesome. Thank you,
Yeah.
Laura.
Thank you.
Okay, so it's pretty hard to follow Laura's talk being all about how do you actually communicate something highly technical in a way that's understandable to users. And this is a highly technical talk filled with jargon, which, oh well, we'll see how we go. For those that are used to my talks, they're typically a lot rambling, but we'll get somewhere in the end. Talking today about Swift data and particularly history tracking, which is a new feature released in this year's releases, so iOS 18, macOS 15, visionOS 2, watchOS 11 if you're crazy enough. Actually not even sure if it's supported on watchOS, but if you're running a database on watchOS, you're probably doing something wrong. Okay, the why of history tracking. With apps these days, you tend to fetch data from a database at a particular point in time. So say you've loaded a screen, everything is fetched at that point. You want to show it, you show 5, 10, 100 items on the screen, and that's all good for that point in time. What then happens, sorry, hay fever is an absolute bitch at the moment, so my voice is just bad, but we'll get through. So, okay, the why of history tracking. Got data on a screen, that data is for a point in time. Something happens and your data gets updated. You then are faced with an issue of, well, how do you go from point A to your new point B? That's the why of history tracking, to be able to go through that. The where is a bit more about, okay, so you've got device A is your iPhone goes into your pocket, you load up an app on your Mac, you do a few things, those two devices need to sync. Chatting with Fletch just before, he mentioned about how do you then resolve conflicts, and I said, that's a good point, I don't know the answer. For a lot of Swift data stuff, you've got a fair bit of Apple magic happening, which is around the, there's a particular core data term I'm trying to remember, which is, yep, okay, that term's gone, but it is to do with syncing your core data store up to your iCloud, so CloudKit, and just doing all of that and organizing the changes and the syncs and everything, which for a large part is Apple magic, mainly because we don't have any actual visibility into what happens there. Okay, that's a bit of a ramble on the where. Now we look at the how. So the how is, what does this actually look like in code? For those that have been around for a bit, there is a land before time, and by that, as well as a really cool movie, is NS Fetched Results Controller, which is how you would get an idea of any changes to a core data store back in a world of UIKit. So let's have a look at how you would create one of those. The Fetched Results Controller, you provided a request. All of my code examples today are going to be very high level, mainly because I'm wanting to give a good idea and understanding of the overall context rather than the specific, here is how you want to solve it in code. So put in a request, your managed object context is your interface between your stuff and the actual store. If you want to section it, You can do that in the fetch results controller, and you can also cache it. But the magic really happens in the delegate, where when you set up a controller, you say, here is your delegate. Typically that's just the view model, or if you're really after a world of pain, the view controller as the delegate. And that way, when a change happens in your fetch results controller, it will say, okay, delegate, here are all of the changes. So go run your code. This code is taken from Apple's documentation. As you can see there, it's dealing with the table view, so good old UI kit. Couldn't find an Objective-C version of this. That would have been troll, but I've got it here in Swift. So when you get the changes, it'll look for things like, it will give you details around your inserts, your updates, your deletes, and stuff like that. The fetch results controller is designed around having your data returned and stored in an sort of a sectioned array, really, because you've got a lot of these calls, words are failing. A lot of these calls use index path, which has like your section and your row. And that maps well to table views and collection views and all the stuff from over 5 years ago that most of you either don't know about or have completely forgotten about. Anyway, so what happens here is you just go through all of your changes, and the controller will say to the delegate each time there's a change, here's a change, here's a change, here's a change. So if you're doing like 1,000 changes, you'll get this 1,000 times. Becomes messy and slow and all of that. Now we're on to the fun stuff. So we've seen what it used to be like with fetched results controller. Now we've got it with the history tracking. With history tracking, you are dealing with points in time. So when you ask your context for everything from a point up to a point in time, you get a token, and you just store that token so that the next time you go, okay, give me everything from token to new latest point in time, and so on for each change. In order to create these history transactions, you need to create a descriptor. You then assign a predicate to the descriptor. This code example is using the predicate macro to define it, which is nice, very Swift-like syntax. And here, all we're wanting to check is that the token is newer, which is pretty cool. Once we get all of those transactions back, we then need to do our iteration over them and go, okay, is this a change we're after? So we look at the transactions. A transaction is a collection of changes. Those changes can be everything that a context has done up to a save. Even with your context, you can do transaction blocks in it, which is good if you want to do unrolls and stuff. There are a few different ways of handling it, but this is what it is. Each transaction has a change, and those changes are your inserts, your updates, and your deletes, or an unknown fourth thing that may or may not come about in the future, which we're just handling there. So for inserts, you would want to do stuff like, okay, make sure that any associated data is updated and stuff like that. For your updates, this is are we displaying our particular change, or sorry, our particular object on screen? If we are, we want to then go ahead and update it on the screen. Deletes, again, are more for the particular removals. This code example is around a single database object being shown on screen. So the only changes we're interested in are the updates to that value. We could be interested in deletes as well, because if there is a delete of this particular object, we would want to visually pop back our navigation stack, dismiss our modals, something like that, in order to display to the user that this particular value isn't there anymore. Now, all of this is good in a very linear fashion, because with, say, your fetch results controller, Apple's underlying systems are telling your stuff, here's a bunch of updates. With this history tracking style, you are going, okay, please give me every update from a point in time. Now, you could do that on stuff like on a peer callback in SwiftUI and stuff like that, which is pretty much this thing has come on screen. Is it out of date or something like that? There is another option, and that is tying it back into MS notifications or notifications. NS, not many people, sorry, not many people know about the old NS prefix, so it's just a notification in Swift. What we want to do is listen to this and then go, okay, put it onto a async stream or something like that, and then your code will observe changes on that stream and go, okay, we have a database save, please give us every new transaction, and then do your iterations through that. Model context.didSave is there for the notification name, so it's a very swift way of handling it. And that's pretty much it for the talk. Did anyone have any questions? Have I completely bamboozled everyone?
Did you like using it?
Yeah, it makes a lot of sense. It really fits in with a very swift way of writing everything. You're not having to sort of deal with publisher streams or anything like that. Fetch results controller itself, you would need to do magic to get the results into a publisher stream or something in combine. Doing it in an async concurrency way is a bit nicer. You can see the linear flow of the actual code a lot there, so you've got less cognitive load when actually trying to understand what's going on.
Any more questions? No? Well, thank you, Amy.
have you got the Mevo app on your thing? You can slip it up a little bit. Or I can step back. Either way. All right. So, bit of context. We were short a presenter last month. So I whipped this out. This is actually a copy of a presentation that I gave in May at DevWorld. The tickets for DevWorld were quite expensive this year. Worth it, but quite expensive. So if you're unable to make it to that, this is your chance to see some of the content, basically. We were going to do this last month, but issues with proxies and other things meant, we actually got the first legitimate use of the technical difficulty slide, I think, last month. So, but there was some calls or people who were disappointed that we couldn't do this last month. So we're going to rehash it this month, even though it's a little bit of a repeat. All right, anyway, let's get going. So the bulk of this is actually going to be code and demo, so don't worry too much about slides. The first probably 30% will be slides, just to give you a bit of context if you don't know what OpenTelemetry is. If you do know what OpenTelemetry is, or telemetry in general, you can probably go grab another drink and come back in about 5 minutes or so, and we'll get to some new stuff. So that's probably the first bits. First 3 bits will just be some context setting, and then the last 2 bits will be where the meat is. And hopefully we have prayed to the demo gods this evening because it didn't work so well last time. Everything I think is working all right now, so we'll find out soon, I suppose. Let's crack on. So what is distributed tracing? First, this is going to be the really basic intro to what it is, or more generally, what is tracing? This is probably where we all start when we're trying to figure out what the hell's going on with the code that we write, right? You've got print statements, you're using NSLog, or you're using Logger, depending on where you are in your Apple logging framework journeys. We're probably all on Logger by now, right? But print will never die. Print lives forever. Go print. You might even, if you're pretty good at it, you might even capture some of this and send it off to your backend so that you can actually, have some idea of what's going on. More likely, you've probably picked up a New Relic or a Dynatrace or something and running with whatever the default out-of-the-box tool that your business has asked you to use, right? But this is all pretty basic, so we'll go back to the basics. You can see in this example flow, someone's tapped on a transfer button or a transfer confirmation button, or tap the button. We've made a call to make you can guess the bank references because I work for ANZ. I think I skipped over the intro bit, but that's all right. You make a call to your API to do the transfer. You might get some data back about the transaction that was made, so you can populate your local database, that sort of thing. And then you might show a receipt screen to your user. And that's a pretty straightforward journey as far as that goes. You might also, on the last line, if you're doing things reactive, update your transactions screen to show the newly inserted transaction data. That's fine. It's all very helpful. Let's break this out a little bit more so we can see what we're doing, right? The next step on your journey might be something like this, where you can move on to structured logging rather than just straight text, one line of text. If you're using something like SwiftLog, and if you've done anything on Swift on server, you'll probably have a little bit of that in your life. You can pass key value pairs into SwiftLog now to add metadata to the log event. And then bonus points if you send the SwiftLog stuff or your other structured logs to somewhere like even an S3 bucket or somewhere where you can actually see them. Hopefully you're storing it somewhere a bit more secure than that, but you send it somewhere and you can actually start to write queries against this. It's basically a table of data. You want to know what's happening for a particular user, you can query on the user ID. You want to know what's happening for a particular URL, you can query on your URL. All of that sort of stuff is there to start getting you some more aggregate information about what's going on in your life. But there's no relationship between any of this. I've pulled out a nice 7-line example. So it's really easy to see what's happening, especially given the previous slide. But if you have tens of thousands of lines of this per hour coming in, for a few thousand users, it can get really confusing really fast. And there's no real way to associate them together as a structured log. But let's try and make that a little bit better. So what if we would try and add some relationships between these? Let's just clean this up a little bit to make it a bit easier to follow. So let's first of all add just a unique ID for each of these log entries. Typically you would use a UUID, but UUIDs don't go well on slides, no matter how small you make the font. So we're going color-coded and we're going a straight number. Makes it nice and easy, right? So let's add a relationship between them. The most straightforward and easiest relationship, and the one you get the most benefit from, is the parent log. So you can see the relationships we've got here. That's in number 2, when you tap the transfer button, it does 2 things. It calls the post/transfer, and then it calls the number 4 as well, gets the transaction details back. You can see that number 4 triggers the insert transactions data. So when we get the response back from the transactions table, we insert it into our local database. We can see it's actually the insert statement that triggers off the select, which means it's probably a reactive reload of that information that's coming through. And then the very last one is we're showing the transaction receipt screen, which is actually triggered by number 2. So that's actually the tap transfer button that comes out. Helpful, but again, tens of thousands of that, not so good. So let's change how we're representing this a little bit. Magic move, such a good thing. Yeah, the magic move always deserves a clap. And let's put the names back in so I don't have to try and remember numbers, makes it easier. So this is actually a trace, right? Rather than individual log lines, this is a trace coming from a root action or a root span. To be more specific, this is a timeline view of a trace. We had the linear view before. This is more of a timeline view. So I won't run through all of that again, but you can see it encapsulates its parents in the vertical, and then it's obviously x over time left to right, which I probably should have put as a graph on the thing. Doesn't matter. I'm hopefully not giving this presentation for a 3rd time, so I'm not going to bother updating the slides. So yeah, you tap the button, makes a couple of API calls, it deals with the API response. There's some other things that are kicked off reactively, but you can see it all in a nice visual timeline of what kicked off what was related to what, all of that sort of stuff. What else did I have to say about this? Oh yeah, but this is a great thing, and if you've got this, it's very helpful. But this is a talk about distributed tracing, not tracing. What makes it distributed? Well, if you propagate your trace information and your backends are logging to the same data source or data store as your front ends, then that trace information, which starts with you tapping a transfer button, can include on the one tree diagram or timeline view everything that your backend does as well. And this is when it starts to get really good, because you're not going into, say, New Relic, figuring out what's happened in your customer app, and then going to a different system like Splunk or a different log ingestion tool, trying to match up source IP addresses and times to figure out where the call came in, and then figure out what happened on the back end. One tap and it's all there, all on the one screen. So you can see when you call tap transfer, the back end does some validation, does some magical fraud checking thing. We even call out to a third-party unicorn service to do our fraud checking, because that's how bank fraud checking works. I'm not recording this, right? Whoops. The secret source. And then we post to a ledger, for example, and then you've got your second call where we would get that ledger, and then so on and so forth. So that's a trace. All right, let's talk OpenTelemetry, because that's the specific bits that I wanted to get to tonight as an introduction. This starts in the same place that they all start. And it's actually, is it 14? Yeah, 14 is pretty close, actually. There's quite a lot of different tracing standards that are out there. But unlike the typical scenario, this one, the industry actually got together and worked on it together. So fingers crossed, if this one is fit for purpose, we won't get to 16. But who knows, right? I do actually have some numbers here. So there's 66, 68 different vendors who had their own proprietary protocols, got together to come up with OpenTelemetry. And yeah, most important bit for what we're concerned here is this is an open standard, and 17 of those 68 vendors have a full open source offering for their backend data and data ingestion. You can run it all up in a container if you need to. You know, especially if you're concerned about privacy and don't want to hand it over to some your Google and your Firebase or your New Relics or those sorts of things, you can run it locally. You can run it on your own little server, and you're responsible. You know what happens to the data. And you can also say goodbye to vendor lock-in because the typical setup for this is to run what they call a collector, which is basically a proxy. That then means you can route telemetry where you want to. So if you want to send really, sampled data, like high-level data to your analytics tool, you can do that. If you want to send really granular data down to a log somewhere, you can do that as well. But the best bit is, if you want to break up with your current vendor, just start sending your data somewhere else. Obviously, history is a bit harder, but you're not stuck with them forever. That lock-in is a lot less. So, OpenTelemetry. OTel actually has the 4 different types of signals that can be sent. Traces, metrics, logs. Logs I don't think we need to explain. That's pretty much the structured logging example that was there before. Metrics is very helpful, but we're here to talk about traces tonight, so we'll focus on that one. In OpenTelemetry parlance, what is a trace? I took that off from direct off the website, but we already really covered that in the first section. The only thing that's probably different is that each of the individual log lines in OpenTelemetry is called a span. So each of those spans is on the left there, on the right. Right, your right, my left. And you can see that they correspond pretty closely to the ones that we had on the diagram in our first section, because this all come from the same data set. And they also have unique identifiers. So you can see the trace ID is the one up the top. So it's all the way through. The actual spans themselves typically represent a named block of code. So you're running a block of code. It takes a certain amount of time to run that code. You have some context around where that code was started. So it was started within a trace, what its parent span was. You usually give it a name, makes it helpful. And then you can add attributes to it, which is the metadata that we had in the previous bit. And the last bit there, in some senses, spans and functions are the same. In some, they're not. You might break your functions up nicely for unit testing, but it doesn't really make sense to have 4 functions representing one larger block of code in the thing. The granularity is entirely up to you on all of this sort of thing. And the last bit is when you cross system boundaries. How do we cross system boundaries? So when you make that API call, you tack in what they call a trace parent header from the W3C trace context spec. Again, another open spec that they built on top of. You pass in that trace parent header, which has the trace ID, the span ID that made the call, and any flags that we need to pass across. And then in the server side, they consume that, and then they start their own tracing from that as the parent. And then when you end up in the tool, you can see the parent cross the system boundary. And we'll show you that in a minute. All right, skim through this. Practical bits if you want to actually have a go at it yourself. The first thing is do not use the official SDK. It's garbage, absolute garbage. It's basically just as somebody's run the Java SDK through Copilot or something. I don't know, but it's a horrible thing, and it's not very Swifty at all. So don't use that. Apple provides some things in this space. They've got the Swift distributed tracing one, which is the one I'll use in the example. It's designed, and these are all designed for Swift on server, though. So while they do work with in apps, there's a few hoops you need to jump through to get them to actually work properly with iOS. It's one of those few libraries that works better on macOS and Linux than it does in iOS and watchOS and family. But their stated goal is to be flexible, so while they're not specific to OpenTelemetry as well, you can hook into the OTel exporter, which is the one that they recommend there as well. Okay, 2 bits of code, 3 bits of code. To create a span, really simple. You just go try array with span, or there is also non-async and non-throwing overloads as well, so whatever you need. But the trick is to call with span, give your span a name, and then do what you think, whatever your thing is inside of it. That's it. Just wrap it in the closure block, away you go. To add attributes, the first argument that I was ignoring before is the span. You can just go ahead and tack the attributes that you want onto it. So if this is an example for a post call to an API, and we'll actually go into a bit more code for this in a minute. But yeah, same thing with span, post to path, add in the, somebody fix that. So it says post instead of get, anyway. Nobody picked that up on the first round. It's funny. But yeah, so you do that and then you make your call like you normally would, right? It's designed to be a minimal wrapper around what you're already doing. Oh, I spoke to the slide already. Okay, you can skip that. There is some good news though. If you're in Swift 6 land or in Xcode 16, you don't need Swift 6 for this one, just Xcode 16 is fine. You can write a function body macro that does the same thing. And it just means then that you've got your method, you can attach a @trace macro to it that does very much the same thing. Nobody provides this yet, I don't think, in any of the frameworks, so you'd have to build it yourself. But I also haven't looked at Swift distributed tracing since May, so maybe they've got a... Do you know something? You had a funny look? No? I have written one of these myself. It's pretty straightforward. It's very, very easy macro to write. But then it means that instead of having to do this every time, that bit's, the boilerplate is just done for you. Yep. Copy paste. It's great. Absolutely great. All right. So demo. All right. So I have been 15 minutes on slides. We're still at 7:25 though, so we're doing okay. So we'll jump into a demo to run through some things. We'll get a quick overview of the app architecture first. And before that, I need to introduce you to BockBank. So BockBank is a brand new neobank. This is one I use for all my demos now. And it definitely wasn't written in 4 days before the conference talk last time. It's really definitely a highly secure and performant banking institution. And it's got a reputation for disruption, innovation, and trend settings. And we need to do the reveal. We have t-shirts, yay! If I can get it off. T-shirts are definitely the best bit. Any excuse for a t-shirt, right? All right, let's look at architecture. We won't spend too long on this, but it's just basically to say we have a server. Everybody has a server. And in our server, we gave each customer a SQLite database. No sharing data with other customers and their dirty, unwashed money. You'll get your own database, so there's no chance of any cross-contamination. Everybody gets their own database. And not entirely at all, because that's easier to write with GRDB than it is to try and do Postgres on the back end. So nothing like that. When the app starts, we open a WebSocket to the BockBank API. It syncs your backend database with the client-side cache. Pretty straightforward. Any changes that occur to your backend databases are automatically replicated down that WebSocket. Another reason for using GRDB and its value observations. Hopefully when we get into demo, you'll see that the traces run all the way through the chain too, and they should. I check that. And most importantly, because we are a lovely progressive bank, everything is written in Swift. Front ends, back ends, all in Swift, all in one project, because that could never possibly go wrong, right? And the source code for this is online if anybody wants to play around. It's all up on GitHub, has been up there for a while. Haven't broken it anything yet, I don't think, so it's good. Let's switch over to demo time. And let's see. Mirror. No, I don't want to mirror to any of those. Is that working? No, that's just mirrored to my phone. My other laptop. Sorry, Pat. That was absolutely not meant to happen at all. Hopefully the stream stayed up. Let's do this the old-fashioned way with the settings. Use as main display mirror. That's better. All right. So what's in my demo notes to run through? Show app in Xcode. Everybody knows what Xcode looks like. You can see in my project, we've got the main app, the BlockBank app is up here. The server stuff is in the same project down the bottom here. And you can see in the main apps package that we have a dependency on the server as well. So we share code between the server and the app. Makes it nice and easy. If we go down to the client, the main thing we share between them is their data models, so we don't have to have any sorts of inconsistency, and it means that we're always building in sync as well. It's great for demos. Really good for demos. All right, come off that for a bit. Next bit is Safari. Now, this is let's go back to the home page for that rather than where I was. This is a telemetry platform called Honeycomb. I like their UI, it's nice and easy, but they are a paid vendor, so it's all the niceties that come with it. They do have a free tier, and I can recommend them, they're quite good. But yeah, if you want to stick in open source lands, you've got things like Grafana or Jaeger, and one other one that I can't remember off the top of my head. But those are the main ones. And as I said, there's 68 different vendors. Most of your big tools support it now, so Splunk can support it, all of that sort of stuff. Everybody supports it. So this is the overview of all of the spans that are coming in for the server. And there's not 2,000 and whatever it is, because there's several different fake things doing postings all over. Fake data is good, makes stuff for nice demos. So we've had 2,617 spans traces come through in the last 30 minutes. And this is the server, as I said. We can switch over to check the app. And the app won't have anything because I haven't done anything in the last 30 minutes with it. But if we expand it out a little bit, or a bit more than that. I was doing testing yesterday, right? Yay! So we saw 5 traces in the last 24 hours when I'm doing some testing on that one. The difference between the two is just how we're grouping them. We group them by service. They create a new data set for each service. You don't have to group them this way. You can group them however you like. All right, let's have a look at some boards, and we'll switch back to the project that has data, because that'll be more helpful. Am I doing boards or queries? Boards. So you can create some basic dashboards for the stuff that's coming in. Again, this is all custom. You can see API calls and durations. So most API calls, like the P95 for API calls, is in the 60 to 100 millisecond range. Not because it's local, but because we're just that good. And you can see the different API calls that are being made. Most of the calls come through to the accounts one with some merchant info and other things as well. And I'll show you the app in a second. This will make more sense. And I should have populated some failure data so that looked better than 0, but it is what it is. So what the data actually looks like. Let's go to our query page. So in the last 2 hours from our timer here, we can just run that. We can see my scripts have been running hard, and we've had, what is our granularity? Every 15 seconds. Let's move that to a minute so it just looks an easier story. We can see that per minute we've been getting about 485, 400 and something-ish coming through, or about 8 a second requests coming through. And this is all events, so all spans, everything. Let's have a quick look, dive into something a bit more specific. So you can search and filter on any attribute, including the name. So let's start with the name, right? The span name is the one that we put into the with span bit. So if we look for, no, it won't be post. Let's look for get accounts, get/accounts, and search for that. So this is just the accounts requests, right? So there are approximately 60 per, whatever that granularity is, still a minute. About 60 a minute, or 1 a second, 2 a second coming through. And we can dive in to see what that actually looks like down the bottom here. So we can see for this first event, the time that it happened, and all of the attributes that we've attached to that. So you can see the duration is 1 in milliseconds, so 1 point or 2 milliseconds. The ID of the user, the HTTP method, this is actually a GET this time, not a fake one. The other, the HTTP details, library info. What else is important here? Service name is our grouping. And then the other stuff that's there, so the trace ID is the unique identifier for the trace, and the span ID is the unique identifier for the span. And that's attached to all of them. And you can query on any of this. We queried on the name before, but I could just as easily go in and say, query on this HTTP status code. Like you can actually click on that and say, show only where it has a status code, where it is an error, where it's not an error, filter and drill down all the way through. But that's just, that's a structured log. You can do that with Splunk as well if you want. The cool bit is when we get into this. And this is just the server-side trace because there's no actual client running. So we'll get into that in a minute. But this is the trace as far as the server is concerned. You can see we've called /get requests, and it has done a database query, and it is called, to do that, is called select star from account. And the user that's involved was on that. All right, so that's enough for that bit. Let's look at code. Oh, let's look at the app. That's what I'm doing next. So this is our app, BockBank. It's maybe heavily inspired by the ANZ Plus app, but I don't know if you could tell, but it looks pretty good, I think. I spent all of 3 hours trying to come up with that nice layout and get it looking good. I think I pinged you at like 11 o'clock one night to get it fixed up. Yeah, thanks, Pat. So that's it. It's syncing all of this to its local client. It has the, obviously, list of transactions. I don't think I have a transaction detail screen. No, I didn't do that. But we have the account balance. This is your transaction account. It does support other accounts as well, but you can't see that in the UI yet. But what it does do, and I'm gonna, all right, let's risk it. Here's one I prepared similar. Hopefully they're connected to the same, they should both be connected to the same server, but who knows with demos. Let's do a transfer. So if we want to transfer from our transaction account to the savings account, and we want to transfer, let's say $33, we do that. Yay, it works. I'm amazed, absolutely amazed. And you can see both are in sync. Right, so that's a pretty basic demo as far as that goes. The real magic is when we come back to this, and this is where we find out how good the demo actually was. So we go to query. Let's go to the app, and please let there be, yay, actual data. So what we want to do, let's find that transfer request that we just made. I don't remember what I called this anymore. Let's have a look. Post/transfer sounds good. Tap transfer now. I wonder if it works that far deep. All right, so we can find, this is the trace that we just did. And we can click on that, and we can view that trace, and fingers crossed, there we go. Very good, it works. So you can see here everything that just happened on both sides of the fence, and not only both sides of the fence, but more. So you can see we tap transfer now. That caused it to trigger a request to /transfer. That's great. And then we crossed the system boundary. So we've gone from blue to green, and colors are done automatically. But we're now running on the server. So this is what happened on the server, all associated in the one tree diagram, so you don't have to go try and figure it out and do the correlation yourself. It's all across that way. We can see we did a magic fraud check, which took 320 milliseconds or so. I may or may not show you the code for that. And then we can see what it actually did with it, right? So the server, it made a select call. It selected star from account, where ID equals something. So it's grabbed some account details for a specific account. It's done that again. So select star from account, where ID is something. We've then made an update account one, right? Where we've updated the accounts and saved it back again. We've done the same again, updated accounts, saved it back again. We have inserted a transaction. We have inserted another transaction. And then we start sending stuff back down the WebSocket stream to the client. And you can see here, we're sending the transactions that we just did, and we can see the app receiving that transaction. Again, same thing. So we've gone full round trip, all in one tree diagram, no needing to figure out what's going on. And you can see that the app received the transaction, it updated it, or it attempted to update it, because GRDB will do an update first, and if that fails, it'll go back to an insert. So it attempted to update it, and then it inserted the transaction. It sent the second transaction, did the same thing. It sent the update account details for both of these, and you can see we're getting them coming through. Update account details there as well. This is then, because I had two devices running side by side, it sent it to all of them at the same time, but I didn't quite have that working for the demo, but it sent them to the other devices as well. Oh no, this one did work. But yeah, so you can see we've sent it to two different end user devices. That's come through, and that's end to end, full tracing set up there, which is very helpful. And that's all I have for demo. Oh, code. Right, so I knew there was more to this. Let's kill that. All right, so code. So we start here. Actually, I should just be able to search for tapped transfer. Oh. Nope. Am I on? Nope. No. Trapped. That's how I feel right now. Oh, come on. There we go. Okay, so you can see we had a transfer form, and we're doing a span inside your view. Probably don't look at this, Pat. Don't look at this, Pat. Yeah, don't look at it.
I like code in general.
So you can see where the user has tapped on the button. We then go and call the payments client to make a transfer, which then calls this bit. And all of that does then is creates a transfer request, calls a post request on /transfer with the request body that we put together. The request is just the source account, target account, the amount you want to transfer. If we then have a look at that, you can see this is, we're using async HTTP client here, I think. So this is just setting up to make a post request with the JSON format, blah, blah, blah. This is where things get interesting. So same as what we saw before, we just call with span, we call the method the raw value, so post, and then the path that we want to send. It's a client span because that's just nice with the way the spec works. We set our attributes, so we do all this manually for this particular one because it's a demo. We set the host, scheme, targets, all of that sort of stuff. We then create the request. We add in that span context. So the span context is how the Swift distributed tracing knows where you are in the current path of the stack, and it does that using task local values. So it knows where you are. Grabs the span context. We inject the span context into the headers, which sets the trace parent header. And then once we've got all those headers, we log them. So we can actually go back over here to this one, and you can see, I think, HTTP header trace parent. Damn it. Damn it. Too much zoom. So you can see it's set, right? It's set the host, set the method, content type, and the trace parent header has come through. That's all there. Lovely user agent, all of that stuff. We make the request. We update the response once we've got it back. And that's it. And that all gets sent off as it goes. We can then have a look for the last bits of this demo is to what happens on the server code, because it's all in the same place. First thing we have is we're using Hummingbird for this one. I don't think it's Hummingbird 2, I think it's pre-Hummingbird 2. But we set up a middleware to do all of this, the tracing for us. Hummingbird actually has something like this built in, but I needed to do a little bit of extra stuff. So you get all of that for free with Hummingbird, and Vapor has the same if you're running Vapor Stack. They have all that for free. So you handle the request, we grab the service context, and then what we do is we start a span with that service context that we've pulled out of the headers. So that's how it then links it back to where it came from. And then I won't go through that again because we're just updating the attributes on the other side with all of the HTTP details. that we're supposed to have. Blah, blah, blah. I don't think there's anything in particular there. We do save somewhere in the middle here, we save the current span into the context for Hummingbird, so we can, in our other middleware, inject and update things. So this middleware does some authentication, access control, or it will eventually one day. And then we just, once we've figured out who the user is, we add the user to the span so you can see what's happening. Let's see you track all that through. And then, so this is where we receive the post request or the transfer request coming through. We do some magic fraud stuff after we've decoded it, and then we just make the transfer in the repository once we're sure that it's a secure and legitimate transaction. And this is where most of that bit comes in. So we write everything to the database, we fetch the source account, we fetch the target accounts, which is those two fetches that we saw here. There's probably jarring going from white to black. So those are the two fetches that you see here. Then we've got two updates and two inserts is what we're expecting to see. So we make the transfer by decrementing one account balance and incrementing the other. And then we create some transaction records for each side. One the source transaction and one was the receiving transaction. And then the two updates that you saw were us saving the account balance. And then the two inserts you saw were saving the transactions. And then we send, I won't go into the other bits, but that's pretty much what you see for all of these bits here. So let's see if I can switch this off better than I switched it on. No, we're just going to display settings. I don't know why they made this so hard. Stop mirroring. So that's it for demo. And it's going to wrap up. That took a lot longer than I remember it taking the first time. Hopefully that's been a helpful introduction to distributed tracing. The few things that I wanted to actually before I summarize, there is one last thing to come. And this is the most important bit, right? Even though you might be getting rid of your Firebases or your New Relics, getting away from a vendor and running something yourself, doesn't negate the fact that you still need the user's permission to do any of this sort of tracing stuff, and you should still always respect that. If it's revoked, stop tracing. Same as always. There's nothing here just because you're doing it yourself that somehow makes it better or more palatable to snoop on your customers. Same rules still apply. That's it. That was it. The source code is there. I think that's the QR code for the source as well. That's my Mastodon. The bits that we wanted you to take away from this is you can get away from your vendors. Open telemetry is a thing. It is still quite new though, so you'll be implementing things yourself, but that's actually a good thing generally because it can be specific to what you're actually building, what you're delivering, and there's no swizzling or magic involved. You're not just picking up a New Relic and whatever data they give you out of the box is what you get. You're doing it yourself. That's it. Any questions? Questions? That way.
I noticed lots of question marks in the logging, which looked a bit kind of like SQL statement. Was that intentionally masking sensitive data, or
that's just how I did my GRDB integration?
Okay. Do they have some sort of special thing for intentionally masking data?
No. Yes. So at the collector level, there are redaction rules that you can set, and they do have some smarts around that. But as always, you tend to want to rely on that yourself. In this case, the GRDB to span stuff I wrote myself based on SQLite tracing, and we take the prepared statement, but not the detailed statement. So that's just what we get back from SQLite before we send it up. But yeah, you can do all sorts of redaction and routing and stuff in the collector if you like YAML. If you don't like YAML, don't look at the collector. It's one gigantic YAML file, basically.
Thanks for the talk. It was really interesting. I'm really curious. You were saying don't use the OTel base SDK, the one they provide. I've used that myself, and it is very, very, very messy. But you said that you had to do a lot of workarounds to get the Apple server SDKs to work properly. I was just wondering if you could elaborate a little bit on that.
It wasn't so much the, wasn't so much, and I don't remember, you'll see it because I had to fork a couple of things, and you can see what commits I've made in the demo repo. I think it was more to the OTel, this one, the OTel Swift library, because there's a Swift on server thing. There's a few cases where they don't support iOS properly, and it's just a couple of conditional compilation statements, I think, from memory. I don't think it was anything too dramatic, and I did go to upstream those and then properly forgot all about it after the talk. So yeah, it wasn't too much, but Swift distributed tracing, I think, worked out of the box without issue. But yeah, because Apple platforms are not their target, you can sometimes find a bit of edge cases on iOS and other platforms.
Okay, this question may be a bit out of context, but
Okay.
how do you deal with retention policies on your data?
Good question. That really depends on your vendor. In this case, for Honeycomb, they have retention policies that you can set. I'm not mirroring at the moment. Do I want to risk it? I still got settings open. Let's risk it. Mirror. So for Honeycomb in particular, if I go to, I think it's team settings or data settings, might be data settings. For each of my data sets, I can, yeah, maybe something. It depends on the retention. Here we go. So in Honeycomb, you've got some level of control over your retention. This is set to 60 days at the moment, and that's their defaults. I'm pretty sure that's their defaults. But if you're rolling your own open source backend, Grafana Tempo has settings for that. But if it's all on your own infrastructure, that at some point you can just go in and say delete all where date older than as a cron job if you had to, right? That's part of the benefits of taking ownership of all of this sort of stuff, is that you're not at somebody else's mercy. You own the data is yours, you can delete what you need to delete. Did that answer the question? Yep. Were there any other questions?
Yeah, maybe for a completely beginner, so for a single span or a trace, how would you define when should it be stopped? Maybe because a complex system may have chain effect of you receive a transfer, maybe you have UI effect to update your balance, and for a single trace, how would you define this is a single span and it should not extend to another span?
That's one of the benefits of this, is that it's all in your control. You're not beholden to what somebody else says a span should be or a trace should be. For guidelines on that, there are a whole bunch of people have written a whole bunch of documents on what you should and shouldn't do, and it's still early days for this, so there's lots of debate about how you should do that. The Swift distributed tracing is designed to work with async await, and structured tasks or unstructured tasks. So that's a pretty good boundary for what a span should be. If it can run in a task block with task.init or in a function that you can try await, it's a great candidate for a span. If you're trying to wrap a span around a long running operation, that's a lot harder. And you have to ask if there's value in doing that. Actually, I will show one here. I should just leave it on bloody mirroring anyway. So I can show you an example of that, right? If I can remember where it lives in the query, in the blockbank server, there should be name equals, we should be able to see it here somewhere, sync. So the accounts per second, if we look at the visualization for the P95 of the duration, which is maybe not helpful after all. Let's have a look at the trace. No, it's not helpful after all. might be better on the client side, but we've got so this is the WebSocket request, right, where we're doing syncing, and it's keeping the connection open, and when the connection closes, it reconnects. So in that one, I actually dropped it off a little bit because there's not a lot of value in a span that runs for 24 hours. Like, you're going to see a million events. They're not going to have a reliable parent. So that's one of the things that you figure out as you go through. Yeah, probably. Where did you see that?
It's on the first page.
That one? Yes, WebSocket sync. There you go. So I deliberately don't associate any of the events that happen inside that sync. I don't associate with the parent trace because there's no value in seeing a billion, events happening inside that one thing. They instead get associated with the event that triggered them in the first place. So they'll show up in the transfer one rather than in the WebSocket one. And I didn't set up any links, no. Purely, and that's up to you to find where that value is. Like, for long running stuff, if it's going to take for ages to run, maybe that's great because you want to be able to alert on that. So Honeycomb and a lot of these tools have SLOs and triggers built in. So you can see if it starts taking, 4 minutes instead of 2 minutes. You might want to trigger an SLO on that. All of those sorts of things are there that you can do. But yeah, it's really up to you to decide what the value is. And again, that's the good bit, is that you can do whatever you want.
Other one. Can you easily turn it on and off, or like increase the amount of tracing, or is that just your own responsibility?
Yeah, it's your own responsibility. We've had those discussions before about doing that. Like, would be great, like if you had log levels in OS log, for example, where you can just by default send only error traces through to the server, and then you can drop the log level down or increase the log level for a particular user, all of that sort of stuff. You're better off just sending everything. It gets batched up and sent as one blob of, they use gRPC for this. It's all zipped up, so it's binary, pretty small. And then at the collector level, you can filter off that. So you might do sampling by default, but then if there's an incident or something else, you can turn sampling off and just flush all data through. Depends on how much data you like having and how much it costs you to store all that data and all of that sort of stuff.
Yeah, that raises another question. So in your slides, you had that spiel, which I think was Apple's rules about needing to disable or toggle.
Yep, always respect the user's consent. Yep.
If you did that as the collector rather than an app, are you adhering to that rule?
I would say no. But I am not a lawyer, but I would say no, because you're still sending that data off device, even if it's, I think as a hard and fast thing, you respect the user's consent. But if you have the user's consent, what you do with that, you can raise or lower as you need to. But yeah. Fletch.
Is there a Shopify store for buying bank merchandise?
I forgot to do the spiel. I am looking for investors. If you've got lots of money, and want to start a bank, let's go.
What's your interest rate? I'll invest.
Well, we'll talk after.
Right. Thank you, Bok.
Yeah, it's over to you now, Pat.
I'm just going to hold the microphone.
You're going to hold it? All right.
I think so. Thanks, buddy. Thank you, everyone, for coming and watching the talks. Thank you for talking, Laura Shuffleberger. Is that right? Amy Dells and Bok Bank. I was saying it to myself a bunch of. I'm gonna point to the screen here, just for something else. Just a reminder about the other events. Thank you all for coming. But yeah, we've got coding night next week on Wednesday. Bring family and friends. Learn to code. Teach people to code. Hang around. Social night, 29th of October. And thanks again to our sponsors, Mantle Group and REA Group. Woo! Did we clap for the speakers just before? Or did I just say the names and we didn't clap? And we'll clap for the speakers as well. Thank you very much. Okay. And now we're going to finish things off down the road at Mitre Tavern. If you're interested, join us. Great. Thank you, everyone. Okay, great. Thank you.